concavity and the second derivative test. Now, let me tell you all what I mean by concavity. We good, class? Look at the sheet of paper. Which way is it bent? Which way is this bent? That's all I mean by concavity. Which way is this bent? So concavity just tell you which way the graph is bent. Now, if y'all look at this graph I got right here, class. Which way is this bent right here?
Down.
So that's concave down. Where's it bent right here? So you know part of this is bent down and part is bent what? Up. So now we're gonna be determine where it changes this. We good, class? Like for example here, this is bent down and part of this is up. So somewhere between it changing from being bent up to bent down, and that's all they mean by concavity. So let's go straight to the second derivative test. Okay, I'm gonna show you what concavity really means in the real world. For example, we talked about the first derivative on that last test we had, where I gave you this little, gave you a little problem, and I usually had something like, I don't know, I think I call it S of t is equal to minus 16t squared plus 128t and plus 144. You remember doing this one, class? Yes, no?
Mm-hmm.
And we try to visualize this is position. We good? If I took the first derivative, class, remember we call this velocity. We call it v of t, yes, no? And remember that was negative 32t plus what? 128, we good? And if I took the second derivative, that's when we had acceleration. And we call it a of t, or that's the same as the derivative of what? Velocity, or it's the second derivative of what? Position, which turned out to be negative what? 32. We good? So what actually happens is, in real world, the first derivative velocity, that's the rate of change in your what? Position. Acceleration is the rate of change in your what? Velocity. So for example, if you're driving down the road in your car and you press on the, what's that thing called?
Yeah.
Huh? You had the car, right?
Mm-hmm.
Yeah.
Yeah.
You press on that little thing on the side of the brake, what's it called?
Gas.
Huh?
You talk about the gas?
The
gas?
Acceleration.
You talking about the gas?
Let's just check this. Let's not even check the house really quick. I'm sorry. And check the house. Most of y'all got a car, right? It got two pedals down there. One look like this. What's that one called?
Right.
And you got another one on the side. What's that one called?
The gas.
Okay, so we got the gas pedal, we got the accelerator. We good, class? See how y'all call it? This is the accelerator. We good, class? When you press on it, it should do what?
Accelerate.
Go faster.
So it's the same thing, accelerating or speeding up. We good, class?
Yeah.
So that's the reason the rate of change in velocity speeds up. We good, class? So the same thing is happening here. We good? But you know, with my car, if I press on it, I don't mean it's gonna speed up. We good? It might probably do the same thing. So let's move on. So this is the test for concavity. This is the test for concavity. And it's real easy. So we have the test. Now I need to clean up in here. So we have the test for concavity. And all it says is if double prime of x is greater than 0. What about greater than 0? Give me another word for greater than 0. Greater than 0 means what?
Mm-hmm. Bigger.
Huh?
Yeah.
Oh, positive. We good, class? Greater than 0 simply means it's positive. We good?
Okay.
If the second derivative is positive for all x and I, then the graph of f is concave upward. And having the brief class that I have in here, if f double prime of x is less than 0, what that mean less than 0?
Yeah. Negative.
Negative. For all x and I, then the graph of f is concave downward. We good? So that full class now, we'll take this, one of these same problems we got right here, yes, no class? Nah, let's pick another one. We good with this? So let's give you a definition. An inflection point occurs when the graph, when the continuous graph changes from concave upward to concave downward, or vice versa. So right here, class, we got an inflection point somewhere in between here. Remember, this part is down and this part is what? Up. I know I got an inflection point in this one somewhere. I don't know where it's at. We good? We're gonna find it. Because this part has been down and this part has been what? Up. We can show you how to find these. So which derivative we use to test concavity? Which derivative we use to test concavity?
The second
We
derivative.
use the second derivative. Which derivative we use for increasing and decreasing?
The first.
So we use the first. So the test might say, determine where the graph of f is concave upward and concave downward. And I have f of x equals x to the fourth minus 4x cubed. Now, which derivative I tell you to test concavity?
The second.
So what we need to do?
This find the first one, then take this.
What's the first derivative?
4x cubed minus 4x squared. No, 12x squared.
What's the second derivative?
12x squared minus 24x.
What do I do with this then?
Set it to 0.
We're doing the same thing just like we find in critical numbers. We get a class? Now we do then.
Factor.
What are you gonna factor out? 12
Yeah,
what?
12x, yeah.
Times
X
minus.
2.
So that means 12x is 0, or x minus 2 is 0. So what's x gonna be here?
0.
What's x gonna be here?
2.
We're doing the same thing again, we're just using what? The second derivative. What do you think we'll do next?
Yeah,
What do you think we'll do next?
the graph.
We set up that little chart just like we did before class. Only thing is what derivative we're using now?
Second.
So you tell me we got what? 0 and what? 2? What's the value over here you want to test?
-1.
What value you want to test here?
1.
What value you want to test here?
3.
So that means we gotta find f double prime of -1, f double prime of +1, and f double prime of 3. Only difference is now we're using the second derivative instead of what? The first derivative. So now we have, so remember this is my second derivative. So that's 12 times -1 squared minus 24 times -1. And what's -1 squared?
1
So y'all know this gonna go to 12, and then what's this gonna be?
plus 24.
Which is,
36.
and that's positive. So what we know, class, this is concave which way?
Upward.
And then we got 1, so that's 12 times 1 squared minus 24 times 1. And 12 times 1 squared is
12.
minus,
24.
which is,
12. -12.
so that's negative, so this is concave. And then I have 12 times 3 squared minus 24 times 3. And what's 3 squared?
9.
And 9 times 12 is? Oops.
What? 81? No.
9 times 12?
No. Yeah, that's what it is.
And 24 times 3? Is it positive or negative?
Positive.
So here the graph is concave which way? Up. We good? So all I know is this part of the graph is bent like this. This part is bent up here, this is bent down, and this is bent what? Up. And then class, what I tell you when it changes concavity? What I tell you occurs when you change concavity? What I tell you occurs when you change the concavity? So we can have an inflection point at 0, f of 0. And we got an inflection point at what's that? 2 what? F of 2? And hopefully I realize f of 0 is going to be how much, class? That's 0 to the 4th minus 4 times 0 cubed. And hopefully I realize that's going to give me what, class? So that point right there is 0 what? 0. And f of 2 is 2 to the 4th minus 4 times 2 cubed, which is 16 minus
32. Yeah, 32.
which is,
Negative
16.
so that point right there is 2 negative what? 16. We good? Now, on your test, I'm gonna make you go through all this. We good, class? Yes, ma'am.
All the sentences that we break down for each different is called the derivative test, and all these different things, can we at least bring the sentences in on a piece of paper?
No, I think everybody should remember the first derivative is used to check what? Increasing and decreasing. Put this in your mind. The first derivative is used to check increasing and decreasing, and the second derivative is used to check what? Concavity. Now, I'm not trying to get y'all to learn how to do stuff. I'm not. But certain things you're gonna learn how to do on your own and have to read. If every job you got, you're gonna sit there and read what you gotta do for every step, is that gonna work, class? Yes, no?
Depends on what kind of job you got.
Okay, now what kind of job you got? So right now, who you working for?
KBI.
You work from KBI. And KBI says you need to learn this stuff and put it in your head. It's not like a cheat sheet you can bring in. And I will tell you this right now, on the next test, I will be watching everyone. Now, what I can have people in my class can't take the derivative of, I can ask the question, take the derivative of x squared, and you can't answer it, but you can take my test and get everything right. We good, class? There's something wrong.
I agree.
We're trying.
Honestly, it's, yeah, y'all give it a good shot. We good? So all I'm trying to tell you is, Miss Davis, Miss Davis,
Then I'm gonna need some steps.
you're gonna need some steps. I want you to put these steps in your mind right now. What's your major?
Thank the Lord, clinical research.
So if you're doing clinical research and everything you do, you have to go back and look it up. Are you gonna get anything done?
Yes, I do, it's called standard operating procedures. We
So
do
they do want you to learn some standard operating procedures, don't they?
something.
That's what you do the same thing, you learn something. We good, move on? So, Miss Davis, you ever go to grad school?
You have to what?
You consider going to grad school?
No, I'm paying enough tuition, no grad school, it's all right.
You have? We got free money. Pharmaceutical science has free money if you go to grad school. So let's move on. And a lot of people go to grad school and they're making more money, yes or no? Maybe, maybe not.
Depends.
It depends, we good? But if you wanna be rich, is school the way to do it?
Be a member of everything.
We good, class? See how life is? Most people who are rich did not go to school, we good? But, you know. Some people didn't go to school in the other places too now, we good? Let's move on. So Ms. Davis, in order to check increasing and decreasing, which derivative we use?
I need my notes.
So in order to check increasing and decreasing, which derivative we use?
Verse 1.
Very good, so my class know that. So we take the first derivative and say that equal to what, class?
0.
Oh.
So we got f prime of x is equal to 4x cubed minus 12x squared. We're gonna set this equal to 0. 4x cubed minus 12x squared equals 0. What can I factor out?
4x squared.
So that's 4x squared times, when I take it out from here, what I'm left with?
That is
Minus.
3.
So that means that 4x squared equals 0, or x minus 3 equals 0. This means x is,
3.
this means x is,
0.
now y'all get this in mind, you can go through it, anything squared and is equal to 0 is gonna be what? 0. We good, class? So therefore, in that class, we're doing the same thing over and over again. We're gonna set up our little chart, are we not?
Yep.
We got 0, and we got what? 3. Oh, let's put it over here. I got 0, and I got 3. So standard procedure class, we're doing the same thing over and over again. We good? 0, 3. What's the test value?
-1.
What's the value in here? What's the value here?
4.
And remember, we're using the first derivative, so that's f prime of -1, f prime of 1, and f prime of 4. Now, this is the derivative, right? So just put it in. So that